Hello, Algebra 1 students. In this video, we're going to talk about patterns and linear and nonlinear functions. By the end of the video, you should be able to identify and represent patterns that describe linear and nonlinear functions. The next few slides are really going to just be vocabulary words. You can go ahead and just stop the video and write these down. We're really going to talk about linear and nonlinear. Linear is going to be a line, whereas nonlinear is going to be not a line, right? It's going to have a curve in it, or it might have an intersection, like you see below the three examples. So make sure you write down these three examples of linear as opposed to nonlinear. What is a function exactly? Well, you see this input-output machine. You've got your independent variable, which we're going to call x, and then you have your dependent variable, which is y. So our y value is always going to depend on what the independent variable is, your x is. So in between, inside that machine, if you probably noticed this, is much like a computer. You put something in a computer, it's going to give you the results you need, right? It's going to output something. So what's happening is there is a function rule going on inside that determines how the input will produce exactly one output. Okay, that's really the key for a function, is that it's a relation in which each element of the x, which we call the domain, corresponds with exactly one element in the range, the y coordinates. Okay, so all functions are relations. Functions have exactly one input mapped to an output value. In other words, each x value has to be unique, so no repeating x values. Okay, here's some more vocabulary words. Go ahead and write these down. We already went over linear and nonlinear. We went over independent, which is going to be your x values, and then your dependent will be your y values. Thing to think about is, what do we mean when we talk about independent? This is something that won't change. For example, time. We can't manipulate time. There's no way of doing that. Okay, so that's why that's an independent. It's by itself. Whereas a dependent, this variable can change depending on the independent variable. For instance, the temperature, right? You start out in the morning, it could be like 50 degrees, and then by the afternoon, we've got about 80 degrees. So it changed because of the time. Okay, here's just examples of what a relation is. It's when an input is paired with an output. It can be in the form of an order pair, which you see in the first column. It could be a table, a graph, or mapping diagram. We're going to go through those later on in the chapter. Linear functions and nonlinear functions can be represented by using a table, which is also order pairs. They can be used with an equation. Here, this is a formula if you wanted to know what the Fahrenheit was or the Celsius is. This is the formula you would use. You would just plug in. So say, for instance, you're going to Europe and you don't know what does 20 degrees Celsius mean in Fahrenheit, because when we talk temperature, we're talking Fahrenheit. Okay, we can also look at functions by graphing. That's most visually easiest way of seeing it is by graphing it. And the last way we can do this is through words. For an example, when the independent variable x increases by 1, the dependent variable y increases by 1. So that's just an example of words. All right, let's look at an example here of recognizing patterns. Here we're given order pairs. Then we need to graph each set of order pair and then use words to describe the pattern in the graph. So just kind of like remind everybody, when we have order pairs, it's always going to be x, comma, y, right? So each one of these, we have x and we have y, right? We always start with the x value. So in this case, we have 0. X is going to go left and right. Y will go up and down. So we're going to start at 0 and we're going to go up 11. And that will be our first dot. Now let's do the next one. We have 1, 10. We're going to start at 1 and we're going to go up 10, put our dot. Okay, now we have 2, there's x, this is y, 2, 9. So then we're going to go 2 up 9. You can kind of see a pattern here, right? Our first one we went from 0 to 1, so we added 1. And then the second one we went from 1 to 2. Again, we added another 1. So far they're going up. X is increasing by 1 each time. Is this true with the next set? Well, 2 to 3 would be, yes, it goes up another unit. So we're going to graph 3, 8. And then the last one is 4, 7. Okay, and again, this went up 1. So just by looking at this, it's saying that x is increasing. I'm going to put a little arrow each time by 1. Let's look at the y now. So the y is 11, 11, 10. So it actually went down 1, right? And then 10 to 9, it went down 1. And then 9 to 8, it went. So each one is going down. So our y values are going down 1. How could you put that into words? So you might want to just say that when the independent variable x increases by 1, the dependent variable y decreases by 1. That's all you got to do. Okay, so let's identify whether this function in the form of a table is linear or nonlinear. So how do you do that? Well, you're going to want to graph these. Okay, so they've already said which ones are which. So this is your x value, and this is your x over here, your y here. Okay, again, we're going to plot x, then y. So x is 0, y is 0. That's this point right here, 0, 0. Okay, then we have 1, 1. So we start with 1, we'll go up 1. 2, negative 5, we'll go start at 2. Now negative 5 tells us we're going to go down 5. 1, 2, 3, 4, 5. Okay, and then we're going to do 3, 8. So start at 3, we're going to go up 8. So it's a positive. 1, 2, 3, 4, 5, 6, 7, 8. And then 4, negative 8. That's going to be a 4. And then we're going to go down 8. Okay, this is all over the place. So hopefully you can see that this is not a linear function by any means, because if you were to go ahead and put your lines between, this is not a straight line, right? Like linear would be. So this is considered nonlinear. Okay, if it were linear, it would just be one continual line. All right, let's look at the next one. If you want, just go ahead and pause the video and see if you can figure out whether or not this is linear or nonlinear, and then come back and see if you got it right. Okay, so I'm going to go ahead and plot these. So we got 0, 0 again. Then we're going to do 1, 3, 1, and then up 3, 2, 6. So we're going to do 2, and then we're going to go up 6. So far, so good. We got a nice line. And then 3, 9, 3, up 9. And then 4, 12. We're going to go over the 4, hover over it, and then we're going to go up to 12. Oops, this graph doesn't have a 12, so I'm just going to make my own 12. And then we're going to connect the dots. This is a linear function. Well, I hope you enjoyed this video, and you all have a great day. Talk to you soon.